This video is a documentation of proof of concept for an intake manifold design. Took a couple of months in design and changes. Goals were to maximize even distribution of airflow into a V8 boosted at high velocity. Control manifold is the tried and true boss from Ford. This particular manifold has been fully ported, smoothed by Brett Barber, and then done again in-house at AED. Specs for this particular manifold can be found online. It is roughly 600 cubic inches in total volume. Spec is just under 30 cubic inches of volume per runner. These have been increased slightly. Plenum volume just under 400 cubic inches. Runner length listed at 9.3. Measurements in-house show 9, but they're crude measurements. Runner design is stacked one on top of the other in order. So you have an oval, 8 ovals next to each other in line that then transition from a long oval to narrow and then go wider. This transition here is difficult to get volume out of. Overall, an exceptional design. Due to the way they're stacked, there's a V here. Forces air as it's coming in at 115, 120 miles an hour with boost. Forces air around it. It actually does a decent job. I should not say decent. It does an exceptional job on the vast majority of engines up to and including 1200 to the tires, with some revisions, paying close attention to airflow distribution by the tuner. The proof of concept manifold is here. This manifold is 400 cubic inches larger in total volume. The runner length is 9 inches. We transition from round to oval. Volume is 34 cubic inches per runner. Of course, fully ported to match the heads being used on this test vehicle. Can be opened up more. The flange exit at the head is smaller than the inner volume of the runner, so this can be used on larger heads. We have velocity stacks internal. The plenum volume is 570 cubic inches. Nearly double the engine. The key to this manifold is here. We have a, this would normally be a collector on a header. It's made out of aluminum, it's custom, and it's reverse. This is where the throttle body mount goes. We're dividing the airflow into 4 evenly. The area of this internally multiplied by 4 matches the throttle body. We divide this and then straighten the air before it runs into the manifold, where it slams into the roof. There are some design features internal that we will not get into. The theory is the airflow comes in, under pressure at 115-ish miles an hour. That can be, velocity of the air can be calculated by simple math of the pounds per minute of air, the diameter of the tubing, how much the displacement is, blah, blah, blah. And you can also calculate the back pressure in the engine, what the engine's using, back pressure being boost. Theory is it comes in at 115 miles an hour, slams into the roof, kills the inertia, or at least kills the inertia in the direction of travel where it came in, so it does not overly feed the rear cylinders. Airflow spreads out as there's a pressure drop going from the volume of this diameter here, okay, roughly 8.9 square inches, to this huge volume of 570 cubic inches. That way we then can build pressure, which will take slightly longer than building pressure in this, but this is a drag race car, so it doesn't really matter. And as the pressure builds, the engine is now fed with a straighter shot. Runner length was kept the same as the Boss to maintain the RPM band, which is, in my opinion, near perfect. I would have liked to have gone 10 inches, 10 and a half, but the requirements for space didn't allow that. So this is as long as we can go. Volume increased beyond what the engine is likely going to flow. Test vehicle is over here. Many know this. It is a 2016 Mustang. It's now a race car. We have no passenger seat, race seat, no back seat. The engine, it is dark, and I apologize. Let me get a flashlight here. You stay put. Sorry, I'm not good at editing, therefore you're going to wait for me. These heads have been ported. These are Gen 2 factory heads that came on this. We have a built motor. It's 11-to-1 compression using the Ford Racing block. This is a single turbo CPR kit, 8596 turbo. I'm hoping we do not run out of turbo for this test. I'm hoping I haven't already run out of turbo for this test, let's put it that way. This motor is being run on Ignite Red. This test will, well, the control test results at 26 pounds of boost with 18.5 degrees ignition timing on that chassis dyno with these wheels and tires, the radials, put out 1396. I couldn't get RPM, but I have mile an hour. It's a beautiful curve. The next step will be installing the manifold, leaving the boost controller alone, not changing anything, leaving the ignition timing, the cam timing, the fueling all alone. We'll be increasing the manifold volume to 19 liters. Manifold volume is the spec between the mass air and the injector or the valve. This is for the ECU to calculate how long it takes for the air to travel from where it is measured to the engine. That's a minor but critical change. We'll also be removing all fueling for individual cylinders that have been changed for the Boss manifold, and then reading the plugs after the runs. Do our best to maintain back-to-back and accurate results. We will not be using ice in the intercooler. We will not be using anything other than a fan to make sure the engine stays cool, and there will be no tricks of any kind. The tire pressure hasn't been made or changed or anything like that. Airflow will be monitored. Airflow increase since we have a mass air sensor. We can compare the data, and I'll be doing my best to share all of that. Next step will be the installation. I'll get going on that now. Document the spark plugs, the color on the plugs, verify fueling with the manifold swap. This is 1, 2, 3, 4, 5, 6, 7, 8. Color on the plugs. You're not going to see in the video very well. They look extremely even. Aside from one cylinder. This is 7 and 8, number 7. Actually, so number 7 is a little bit different colored on the Boss manifold tests, and it's cleaning up now. Again, this is the same same fueling target, same ignition timing, 18.5, same fuel, same setting on the boost controller. I'm going to get to the numbers shortly, but wanted you to see, well, this is documentation to show that we do have even fueling, at least significantly more even than a Boss, considering yeah, it's looking good. Show you what this looks like. No tricks, no nothing. We did make couple of pulls. I'm going to put them back in now that I've verified, review the data. We had to add a little bit of fuel throughout the entire curve. I'm going to make sure it's correct before I finalize everything and show you guys the numbers. I've got data for the manifold swap, the proof of concept. It's actually, I don't sugarcoat anything, good, bad, or ugly. This is a win because of even cylinder distribution. Plenum made more up top at RPM. We were comparing against one of the best manifolds out there for the price for boost, which is the Boss, and when it's fully ported and done right, it's excellent. Here's the numbers and the curves. Okay, so the Boss made 1396 the other day. SA corrected is 7% correction. Doesn't really matter, everything's accurate. The Atlas manifold at the same fueling, same ignition timing, same cam timing, same boost control setting, made 1392. Blue line is the Atlas, so it actually is outpowering the Boss as it's coming into boost, and it dips down a little bit. Peak torque-ish area, data logging, or dynoing versus speed because I can't get my optical to work. Anyway, up top, the Atlas is outperforming the Boss as expected. Now this is 210 miles an hour, so I could use a gear change. I never ran the Boss higher than 8,000-ish RPM, and this run was 8,500 for the Atlas. So yeah, it makes more at RPM. Is it usable? I don't know. Probably if I want to spin it that high. It's I'm shifting at 7,500 currently, so I'm sure shifting it higher will work. This gain absolutely due to the larger plenum volume. The lack of a loss down here absolutely due to the long runner length. So both of those are a win. The third win is the even distribution of airflow to all 8 cylinders. The spark plugs look even, airflow looks even. Obviously there's not huge dyno gains, but there's more data to sift through, and let me go through that here. This is the Boss data log. I'm going to show you MAF frequency, yellow here. It goes up. We're 14.25, 14.4, 14.3, 14.4, 14.7, 1, 5, there we go. Okay. All right. So it's just trickling in that area, averaging mid 14. Let's pull up the Atlas at the same. We'll do MAF frequency again. Zoom in. Zoom in further. Okay, this is the curve. Now watch, we're 13.3, 13.9, 14.0, 14.0. We are 14.1. Okay. 14.3 we hit right there, right? And 14.2, 14.1. Okay. That means less airflow. That's the mass air sensor. I didn't move it. It's in the exact same spot. It's the exact same sensor. It's in the exact same tube. It's in the exact same orientation. So we're not seeing as much airflow and making basically the same power and even more at RPM. That's a win. I did try to turn up boost, and I think we're just out of turbo. This is a 8596, and I was a little worried that we'd run out of turbo, but whatever. Let me show you how much boost we made to make 1392 with the Atlas and how much boost it took to make 1396 with the Boss. Okay, hold on here, let me get that log up. Okay, this is 1396 with the Boss. All right, pink here is the boost curve. Excuse me, boost curve. And it comes up 65% duty cycle, by the way, right there. So you can see when we get to the other one. Let me get that glare off. Shit. All right, anyways, 25.26, 25.7, 25.5, 25.2. It starts dropping as RPM is up at 7,800. So by 7960, roughly 8,000 RPM, it's 23.88. Okay, that's 65% duty cycle. Open the Atlas. Okay. Again, pink. Notice 65% duty cycle again right here. And, just so you can believe me, oh, they don't have the time, whatever, it's the day. So we're at 23.64, 24 pounds of boost, 24 and a half, 20. We don't even hit 25. Not even 25 pounds of boost. By 8,000 RPM, it's down to 23 and a quarter. So we lost boost and lost airflow, and yet made the same power. That is 25, not even 25 pounds of boost to make 1,391, 92, whatever, on this inertia drum with radials and a power glide with an unlock converter and the gearing is pretty wrong for what we're doing with this. Anyways, I think the Boss is an excellent manifold. Honestly, I mean, it's fabulous. Up to a certain point, if you really want to read plugs and get everything dialed in, which we've done, and we have for you guys out there, we know which cylinders are running more airflow and which ones have less airflow. This, I wanted to get rid of that, and I did. So essentially, we increased efficiency. Okay, less boost, less airflow, same power. I think I'm going to need a bigger turbo to make more power. Chatting with the guys over at Forced Induction, they told me this thing would be good for about 145 pounds per minute of air. We're at 1,400 almost to the tires. What do you think? I'd say we're there. So anyways, take it to the track, turn it down, get some seat time, and have some fun.